RHS Pre-Calculus presents All Around the Unit Circle. The goal of this video is to help the viewer gain a better understanding of the unit circle.
Max is a regular traveling pro, has been around the world several times, but right now he's sitting in math. As he sat at his desk, he began to wonder how he could apply such complex concepts as the unit circle to help him travel around Washington State.
Eureka! I will use the unit circle to define my next destinations.
The only problem was he didn't want to go to 360 places. Which angles should he use to find his destinations?
We will help. We special triangles form the important angles needed to understand the unit circle. I am the 30, 60, 90 degree triangle. I have two special angles. With me, your first destination will be Redmond Ridge.
Hi, I am the 45-degree triangle. I am the fat one. People call me fat because two of my sides are equal, but that's not a nice thing to say. With me, your first destination will be the Bear Creek Golf Club.
But now that Max has traveled around the world, he asks himself,
how exactly does the unit circle work mathematically?
You see, the unit circle isn't very difficult to figure out. Do you remember SOHCAHTOA? This simple acronym defines sine, cosine, and tangent as fractions of the respective lengths of a right triangle. Using this, you can figure out exactly how the unit circle works.
Let's take a look at the 45-degree triangle. We already know that the hypotenuse, which is the length of the longest side of the triangle, is equal to 1 because that aligns with the circle's radius. So let's set up the equation sine of 45 degrees is equal to x over 1. If we solve that equation, we can figure out that the length of both sides of the triangle is the square root of 2 over 2.
Eureka! I've solved my first special triangle.
Now that you know the process of how to solve for the side lengths of the special triangles, we can apply it to the unit circle. Don't forget that since the circumference of a circle is 2 pi r, the circle can also be split into radians.
Whoa, is it just me, or is there a reoccurring pattern here?
You're right, Max. A unit circle is a constant repetition of 3 special triangles. Now I'm going to show you an easy way to remember certain coordinates. Angles corresponding to the 30-degree special triangle will always have the coordinates the square root of 3 divided by 2, comma 1 divided by 2. Angles corresponding to the 45-degree special triangle will always have the coordinates the square root of 2 divided by 2, comma the square root of 2 divided by 2. Angles corresponding to the 60-degree special triangle will always have the coordinates 1 divided by 2, comma the square root of 3 divided by 2. They will be negative or positive depending on which quadrant they are located in.
And let me guess, the coordinates that correspond with 90 degrees will just be the simple coordinates 0, 1 for 90, negative 1, 0 for 180, and 0, negative 1 for 270.
Good job, Max. Don't forget about the 1, 0 for 0 degrees. The last thing I must teach you is all students take calculus. If you look at the circle, it's just an easy acronym yet again to help you remember when each trigonometric function is negative at a specific quadrant. In quadrant 1, all the functions are positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive, and in quadrant 4, only cosine is negative.
Wow, who knew understanding the unit circle could be so easy?